Hi everyone, I'm Tiffany Miller and I manage the support and user education teams that support the BioData Catalyst powered by Terra. And I will be introducing you to workspaces and their capabilities in the BioData Catalyst analysis platforms. Within the NHLBI BioData Catalyst ecosystem, you can take advantage of analysis platforms for all your data science needs without having to wait for your organization's computational resources. This means you can run thousands of workflows on demand. The analysis platforms use cloud vendors like the Google Cloud Platform, and I'll be referring to that later on as GCP, and Amazon Web Services, or AWS, allowing you to utilize their vast data centers for running computational jobs. These two screenshots show the platforms in the ecosystem where you can create and manage analyses in BioData Catalyst, Terra, and 7 Bridges, as Amber went over earlier. You can organize your analysis in these platforms in a workspace or project. You can think of a workspace or project as a place to organize your data, configure and run analyses, and collaborate with others. Note that workspace is a term used in Terra, and a project is the term used in 7 Bridges, but fundamentally these computational sandboxes offer the same capabilities. It is a place where you can do all your data analysis end to end. By virtue of it being a platform on the cloud, you can easily collaborate with others during this process. A workspace or project has granular permissions so that you can control who has access to it. It can be kept private, or you can control who can view it, run analyses within it, or share it. This means you don't have to worry about how collaborators will get access to your on-premise resources or your data sets to collaborate on your project. You can securely give collaborators access to your workspace or project easily. In the ecosystem, you can analyze and access 3.4 petabytes of hosted data. With your ERA Commons ID linked, particular data sets you are authorized to use in dbGaP are accessible and exportable to the analysis platforms. This screenshot shows how you can export pointers to data from Gen 3 to a workspace or project in Terra or 7 Bridges. By pointers to data, I mean the pointers to the physical location of the files on the cloud. By pointing to the data, you won't have to pay for storage of these raw files for extended periods of time. You can make use of the files or portions of the files when you want to run your analysis. Sometimes the data set you want to analyze isn't hosted yet. That isn't a problem though, because you can bring it into the cloud yourself. Users can upload data for which they have the appropriate approval, provided that they do not violate the terms of their data use agreements, limitations, or institutional review board policies and guidelines. There are options for uploading your data to the cloud for accessibility in Terra and 7 Bridges. You can drag and drop small files via your browser or use the command line to upload large files or sets of files. If you already have data in GCP or AWS, you can grant access to those buckets to your Terra or 7 Bridges account so you can use them for your analyses. Once the data is in the cloud, you can start to analyze it. There are a few components required to be able to run software or tools on the cloud. You need a Dockerized workflow. But what does that actually mean? First, you need to get your software or tool dependencies packaged in a way that is modular and can be reproduced on any unique virtual machine or cluster. Docker containers solve this problem. Docker containers package applications in containers, allowing them to be portable among many systems. Imagine when you're running a workflow on a machine in the cloud that your Docker container is an environment running on these machines with all the software, language, and tool dependencies available. Terra and 7 Bridges will orchestrate the use of these machines from GCP or AWS. The Docker container provided ensures that all the technology is there. But finally, there's one other piece that you need. The user must also provide the requirements and instructions on how their analysis should run. So that's the second component, the first component being the Docker container. You need to write your workflow in a language that the analysis platform can understand. You can use the workflow description language, aka WDL, is what I'll refer to it in this rest of this presentation, or the common workflow language, also known as CWL. So I'll refer to it as CWL. Now, you are probably thinking that all sounds like a lot of work to have both of those components, but luckily there is another product in the ecosystem called DocStore that can help you with this work. So you can think of DocStore as like a repository housing popular workflows and pointers to their corresponding Docker images. You can make use of common workflows so you don't have to recreate the wheel. You can also look at some of those workflows and use them for inspiration to write your own. DocStore is pictured here in the screenshot. Docker defines itself as an open platform used by the GA4 GH for sharing Docker-based tools described with either CWL, WDL, Nextflow, or Galaxy. Dockerized workflows come packaged with all of their requirements. So essentially, from DocStore, you can export workflows and tools to your workspace or your project and run them in batches on several samples at once or whatever data type you're working with. But maybe you don't need to run workflows and you just want to visualize your data quickly, compute statistics, or use another interactive app. This is known as interactive analysis and is another key feature of the analysis platform's workspaces. Within your workspace or project, you can spin up a Jupyter notebook or RStudio environment to further analyze your data. There are other apps available depending on the analysis platform that you use as well, and myself and Dave will go over those later on. If you haven't used them before, Jupyter Notebooks are an open source app that runs in a browser. They contain rich text commentary as well as code cells. They can execute any Python or R-based commands on data in real time. So when you send a copy of a notebook with code cells that have been run before to your collaborators, they can view your results embedded right in the IPython notebook file. Your workspace or project is a place where you can also store these notebooks so that you can easily share or collaborate on them with all the data and relevant workflows all stored in the same location, which is your workspace or your project.